This song will help us to remember how to complete the square.
Completing the square, completing the square. Halve the x and put in brackets, subtract the square of that number there. We have completed the square.
Completing the square, completing the square. Halve the x and put in the brackets, subtract the square of that number there. We have completed the square.
Using the song, let us try to find the constants that must be added to this expression here such that we form a perfect square. Remember, we have to halve the x and put in brackets. We'll start off with this all the time by halving the x and putting into the bracket we have plus 5. And we must always subtract the square of this number here. So we will subtract 25. And therefore, we have formed a perfect square for this part of the expression. So the constant that must be added is negative 25. And the perfect square here will be x plus 5 squared. Let's look at another example. What constant must we add here? Again, we'll start with this. Always halve the x and put in brackets. So we will have negative 7 over 2. Yes, we always follow the sign as well. But for the next part here, we will always subtract. Regardless of the sign, we will always subtract. So subtract the square of the number there, we will subtract 7 over 2 squared. And hence the constant that must be added will be negative 49 over 4. And the perfect square here will be x minus 7 over 2 squared. One more example. Yes, we will start with bracket x close bracket square. Halve the x and put in brackets. So we have plus 15 over 2. Or you can write 7.5, that is fine. Subtract the square of the number there. And hence the constant that must be added will be negative 225 over 4. And the perfect square will be x plus 15 over 2 squared. Or you can write x plus 7.5 squared. Now let us see how completing the square can help us to solve this quadratic equation. Does this part of the equation looks familiar? Now let us move the positive 5 over to the other side. So we have x squared minus 6x equals to negative 5. And we have learned previously how to make this into a perfect square. So we will halve the x and put in brackets. So the number here will be, yes, minus 3. And we will subtract the square of the number there. We will subtract 3 squared. And the right hand side remains unchanged. Simplifying, we have x minus 3 squared minus 9 equals to negative 5. Now we shall move the constant term over to the other side by adding a 9 on both sides. On the left hand side, we will be left with x minus 3 squared. On the right hand side, we will simplify it to 4. Are you able to solve this now? Do not expand and simplify as we have learned previously. Instead, we should, yes, square root on both sides. And remember the plus minus sign. On the left hand side, we will be left with x minus 3, and on the right hand side, we will have plus minus 2. What this means is that x minus 3 equals to positive 2, or x minus 3 equals to negative 2. We shall now add 3 on both sides. We have x equals to 5, or x equals to 1. Let us look at another example. X squared plus x minus 5 equals to 0. We will try to complete the square for this part of the equation, and hence we will move the negative 5 over. And hence we have x squared plus x equals to 5. How do we complete the square? We will halve the x and put in the brackets, and we will subtract the square of the number there. The right hand side again remains unchanged. Simplifying, we will have x plus half square minus 1 over 4 equals to 5. We shall now bring the 1 over 4 over to the other side, and hence x plus half square equals to 5 and 1/4. Now having the perfect square, we can easily solve the equation by square rooting on both sides. And hence we will have x plus half equals to the square root of 5 and 1/4 will give us plus minus 2.291. This means that x plus half is 2.291 positive, or x plus half equals to the negative 2.291. Subtracting half on both sides will give us x equals to 1.79 or x equals to negative 2.79. Why don't we look at another example to help us better understand how to complete the square and hence solve the quadratic equation. We will move the negative 3 over to the other side, and now we will complete the square for the left hand side. Half the x and put in brackets, so we have plus 11 over 2. Subtract the square of the number there, so we will subtract 11 over 2 square, and the right hand side remains unchanged. Simplifying, we have x plus 11 over 2 square minus 121 over 4 equals to 3. We will now move the 121 over 4 to the other side, and we have x plus 11 over 2 square equals to 33 and 1/4. Square rooting on both sides will remove the square here. On the left hand side will be x plus 11 over 2, and on the right hand side we have plus minus 5.766. This means that x plus 11 over 2 equals to positive 5.766, or x plus 11 over 2 equals to negative 5.766. Subtracting 11 over 2 on both sides, we will be left with x equals to 0.266 for the first equation, and x equals to negative 11.3 for the second equation. That's all for using completing the square to help us to solve a quadratic equation.